Hi, this is Hamdeep. Welcome to my video on equipment safety. As technical project managers, we need to be aware of safety requirements and incorporate them into the requirements of the project. I want you to be able to guide your vendors or contractors in designing a safe equipment from early concepts. From my experience, modifying the equipment after fabrication in order to meet safety requirements and for commissioning is very costly. Safety concerns will also impact your schedule. And of course, we don't want anyone to get hurt using an equipment we were responsible for. If you have a safety concern, address it from the beginning. Performing a risk assessment on the equipment will allow your team to identify most of them. So let's dig into what we need to look out for. As always, here's an overview of this video. First, we'll look at the importance of being able to lock out an equipment and how it should be integrated in the design. Next, we look at safety devices we can use in our equipment. Third, we discuss pinch point potentials and how to eliminate them. Next are required clearances between our equipment and other objects. Lastly, we talk about the stopping distance, which is critical for robot work cells. Firstly, lockout. Depending on the equipment, it might have different energy sources. For example, the control panel of an equipment will have power fed into it. We want to be able to lock out the control panel after we turn it off. On the power switch, there should be a lockout point where someone can insert their lock. This allows someone to work on the equipment while being sure that no one else can turn it on. If the control panel does not provide a lockout point, the power source at the disconnect should be turned off and locked out. After locking out, we want to ensure that there's no energy in the system. We need to be able to dissipate any stored energy before someone has to work within that area. Any mechanical motion should be blockable. There is a lot of information on locking out equipment, and you are probably required to get training on locking out before working with them. I just want you to be aware that your equipment needs to incorporate lockout points and ways to dissipate the energy so it can be worked on. Be sure to bring it up during design reviews. Next are the safety devices. We have light curtains as shown here. These are typically put at the entrance of a work cell, and it will stop operation immediately if someone or something breaks the light curtain. This ensures that the equipment is not running and there's no potential hazards when someone is close to it, or when an object is getting out of the work cell. Keep in mind that someone should not be able to activate the equipment while someone else is within that work cell. Another light curtain could be added here so the system does not go active while the light curtain is broken. We also have safety scanners which are used for moving equipment. These scanners have a wide view and are programmable to stop whenever someone or something moves in the programmed area. This prevents the equipment from hitting anyone. Next among safety devices is e-stop push buttons. These are installed at accessible locations so the user can stop the equipment instantly if there are any issues. Mushroom-style push buttons are typically used for e-stops. Lastly, safety interlock switches. These switches are hardwired and prevent the equipment from running until the switch is closed. This is used on gates for work cells. Instead of a light curtain, the gate needs to be closed for the equipment to operate. If someone needs to enter the area, they have to open the gate, which stops the equipment immediately. When someone goes through the gate, they need to be able to put a lock on the safety interlock, so someone else cannot close the gate and start the equipment while they're inside. Let's move on to the third topic, pinch points. We need to be aware of potential pinch points and address them from the beginning. Let's look at this example. There's a cylinder which is actuated during a process. Let's say that it is compressing a part. How do we keep the user safe from that pinch point? One way is to have the user set the part and then hold down two push buttons during the operation. This can be done using electronic logic or pneumatic logic. Be sure to check your standards on what the safety distance between the hazard and the push buttons should be. Also ensure that the push buttons are spaced far enough apart so the user does not press them with only one hand and have the other available to be pinched. If your push buttons do have to be close together, have a guard between them so one hand cannot press both buttons. Another way is to put guarding around the hazard. Using safety interlock switches as discussed on the previous slide, it will only operate when the guarding is closed. If someone was manually operating a process, painting the grab points green ensures that the user does not have his or her hand where it could be pinched. Also, if your equipment does have a pinch point, have a sign as shown here to raise the user's awareness. Fourth is clearances. Whenever you have a moving part or equipment and people have to be in that area, ensure that there's enough clearance around it. For example, this equipment is moving close to a wall. If a person was between the equipment and the wall, we want to ensure that they would not get stuck there. At the body level, having around 500 millimeters of clearance is a good guideline. It is less for the feet and the head, but 500 millimeters is really not that much. I recommend keeping that clearance around your equipment whenever access to that area cannot be blocked. Now our last point, stopping distance. Whenever you have a safety device that will stop the equipment, we need to ensure that the equipment will stop before it encounters the object or person that triggered this safety response. Looking at the example here, we have a robot inside a work cell. Access to the work cell is protected with 3 light curtains. This way, a person could not be inside that area and have the robot be active. If the robot did reach light curtain number 2 here, and someone was standing right outside the light curtain number 1, we need to ensure that the robot breaking the light curtain number 2 would trigger the system to stop the robot before it reached light curtain number 1. This also works the other way. If someone was to break the light curtain number 1, we need to ensure that the robot would stop before that person gets to the robot. Another example to consider is that of a safety scanner. If a person walked inside the scan area, we need the equipment to stop moving before it reached that person. I have gone over what I think are critical safety items to be aware of during equipment specification and design reviews. I hope that this has been helpful for you. Please let me know if there's anything I missed and I'll gladly discuss them on another video.